My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 279. In this lecture, we will try to understand need for cross validation. Just recall my previous lecture, what we were discussing using dtrain and 7NN on Amazon Find Food review dataset. I get an accuracy of 96%. We assumed this one, isn't it? It's almost right. There is a small problem with this statement. What is the objective of machine learning? What is objective of machine learning? We are going to very fundamentals. We are going to first principle, the very basics. What is the objective of machine learning? The whole objective of machine learning here is, let's not forget that objective. You are given a data set DN, you do whatever you want, you learn a function F using all of the data for me. What is my DN here? DN is my entire data set. We broken up, let me say, this is my DN, my whole data set. We broken this data set into two parts. First one is, let me say, dtrain. This is dtrain. This is, let me say, this is dtest. We broken up this data set into two parts, training part and test part. By using this particular data set, we use dtrain. We use dtrain to compute. We use dtrain to compute function F. Actually, we use dtest to determine my K. We used this dtest to determine K. In my previous lecture, I derived K as 7 by using dtest. And now what is your accuracy? Let's say using all of my data DN, I learned 7NN, 7, KNN means 7NN, and it's give me an accuracy of 96%. Let it be. There is one fundamental problem with this. What is the objective of machine learning? Learn a function and tell me an accuracy for future. That is important. Just learn a function. I will repeat. Learn a function and tell me accuracy for future and unseen point xq. After learning the function, you must tell accuracy for future and unseen point xq. How accurately I am going to predict. That's important. First of all, I wanted to predict YQ. And also I want to understand how accurately I am going to be on future unseen points. This is very important. If your algorithm does not work very well on future points or unseen points, then it's useless. If it works only on seen points or trained points, then it's useless. If a function that you learned works very well on future and unseen points, then it's good. It is if it works on unseen points, if it works on unseen points, if it works on future points, then I can say it is super. This working working on unseen points, working on future points is super and duper important. It is super duper important. If it works, if it works on unseen points, if it works on future points, then it is super and duper important. It has to work on future points which you have not seen, till now, otherwise it's useless. After productionize my system, if the algorithm does not work, if your review is not seen yet, this is nothing but test set. This is the future point that will come in the future. If it does not do very well on unseen future points, then it's useless. After productionize my system, it must work with unseen data, isn't it? When a algorithm done very well on future unseen point, it's called generalization. This concept is important. What is generalization? Generalization means algorithm must work on future and unseen points. If it works on future and unseen points, then I can say this algorithm is generalized. We can say an algorithm is generalized better, an algorithm generalizes better if it performs well on future points, if it performs well on unseen points. It must work well on unseen points, not just on my d-test, because I have already data for d-test. If it works only on d-test, it's useless. It must work on my future points. If my function performs very well on d-test and d-train, if it performs on d-test and if it performs very well on d-test and d-train, then it's useless. If it works on d-test and d-train, then it's useless, because once I productionize my system, it is extremely important in machine learning to work on unseen data. Your function should work better on future and unseen points. If it works better on future unseen points, it is said to generalized well. Because of our fundamental objective in whole of machine learning is to perform good or to perform well on unseen points which have not seen yet. What are unseen points? Points which are not. Unseen means what? Unseen point means what? Points which are not in train. Points which are not in d-train. Points which are not in d-test. Those points are known as unseen points. We have not seen them yet. That's our objective. The problem here is to determine your k. I am using my test set. To determine k. I am using test set to determine k. To determine k, I am using test set. And what is my whole function? My whole function is a combination of two ideas. It is k. My whole function is combination of k and nn. That is, I can say knn, isn't it? For computing nn, we are using d-train, isn't it? For computing, let me say this is knn. For computing nn, which one am I using? We used d-train. For computing nearest neighbors. For finding right k, we are using d-test. My function has two parts, finding nn and finding right k. If I am using d-train and d-test, if I am saying accuracy on d-test is 96%. Here a big question is, this is one important observation. Can I say that my accuracy, my accuracy on future data, future data or unseen data, my future data or unseen data is 96%. Can I say that? This is very important question. Can I say that my argument is you cannot say this because to determine what is k is we used the d-test. Just recall, to determine what is k, we used the d-test, that is test data set. To determine nn, we used d-train, isn't it? That's what we are discussing. Now on your test data set, that is on d-test, I agree that you are getting, on d-test I agree you will get 96% accuracy when using 7NN. This number 7 I derived from test set, isn't it? That does not mean at all that for future data points, you cannot guarantee that for future points using 7NN, you will get 96% of accuracy because you use d-test to get this particular 7, isn't it? If you did not use d-test to derive this 7, if you did not use d-test to derive this number 7, then probably this accuracy number 96% still works. Because of these problems, we have an idea called cross-validation. Very, very fundamental and important idea in whole of this machine learning. We will introduce this concept using our KNN, that is K nearest neighborhood algorithm. Now let's understand what is cross-validation. I will explain what is cross-validation in my next lecture, in my lecture number 280. Time being, just go through this lecture, understand motivation behind this cross-validation. Thank you very much.